It's that constant, silent companion up there in the night sky. It's been a source of myths, of wonder, and a whole lot of scientific fascination. So today, we're going to dive into the incredible life story of Earth's one and only natural satellite, the Moon.
Okay, so to really get a feel for how special our moon is, let's just zoom out a bit for some perspective. Get this. Across our entire solar system, there are more than 150 moons orbiting the other planets. That is a ton of celestial company out there. But out of that huge collection, yeah, only one calls Earth home. And it's this really unique, kind of intimate relationship that has shaped our world in some pretty profound ways. Which, begs the question, where did our moon even come from?
Well, let me tell you, its story doesn't start with some gentle, quiet formation. Nope. It starts with a ridiculously violent, cataclysmic collision. So let's get into it. The first chapter is all about the moon's wild birth. All right, so the leading theory, the one most scientists are behind, is called the Great Collision. Try to picture this. We're talking about 4.5 billion years ago. A very young Earth gets absolutely slammed by another baby planet, something about the size of Mars. The impact was just unbelievable. It basically vaporized the smaller planet and blasted this enormous cloud of debris into orbit around Earth. Then, super slowly, over millions of years, gravity just did its thing, right? It started pulling all that wreckage together bit by bit until it formed the moon we see up there tonight. So there you have it, a brand new world forged from the leftovers of a cosmic car crash. But what's it actually made of? What secrets are hiding on that ancient surface? Okay, so let's talk size. How big is this thing, really? Well, its diameter is just under 3,500 kilometers. Now, that number might not mean much, but check this out. That's almost exactly the same as the width of China. So if you could just plop it down on a map, it would stretch pretty much coast to coast. And that, by the way, makes it the fifth largest moon in our whole solar system. Pretty impressive. And a lot like Earth, the moon actually has layers. Deep inside, you've got an iron-rich core. Around that, there's a thick mantle, and then on the outside, a solid crust. And that crust, it's made of stuff we're pretty familiar with, mostly minerals packed with magnesium, oxygen, and silicone. But don't let that quiet, dusty surface fool you. The moon wasn't always like this. Way back in its early days, it was super geologically active, covered in a literal ocean of churning molten magma. It's wild to think about, right? Because today, it's a totally different story. It's a world of fine dust, rocks, and, interestingly, traces of water ice that are hidden away in the coldest, darkest craters where the sun never shines. And yeah, speaking of impacts, we're talking about scars. The moon is absolutely covered in them. It's like a history book of every time it got hit by asteroids and comets over billions of years. So that brings up a pretty cool question. Just how big is the biggest crater up there? The answer? It is just mind-blowing. The biggest crater is called the South Pole Aitken Basin, and it is so ridiculously huge it covers a quarter of the moon's entire surface. And its depth? Get this. It's deep enough to swallow Mount Everest. The whole thing. That is one epic scar. So, from its geology to the way it moves through space, the moon's story is completely tied to ours. You really can't separate them. So, let's talk about its role as Earth's constant orbital dance partner. Even though it looks pretty close in the sky, it's actually really far away. On average, you could fit about 30 Earths side by side in the space between us and the moon. That's a huge distance. But even from that far, its gravity is strong enough to pull on our oceans and create the tides. So, have you ever looked up and realized, hey, we always see the same side of the moon? That's not a coincidence at all. It's because of this cool thing called synchronous rotation. Basically, the moon spins on its axis at the exact same speed that it orbits around the Earth. And because those two speeds are perfectly matched up, one side is just permanently locked facing us. That man in the moon, he's always looking right at us. And of course, as the moon makes that trip around our planet, the sun lights up different parts of it. That's what gives us that beautiful, predictable cycle of phases we all know. It's this amazing cosmic dance of light and shadow, right? It takes us from that completely dark new moon all the way to a brilliant full moon, and then slowly fades back to dark again. And this cycle isn't just something pretty to look at. It's actually fundamental to our history as humans. For thousands of years, ancient civilizations watched these phases to track time. It's how they created some of the world's very first calendars. It's all based on the moon.
So, for almost all of human history, we could only look up and wonder. The moon was just out of reach. But then, in the 20th century, we decided it was time to close that distance with one giant leap.
July 20th, 1969. I mean, that's a date that changed everything. It changed our relationship with the entire cosmos forever. It was the moment the impossible suddenly became possible. Because on that day, we did something that had only ever existed in science fiction novels and movies. The Apollo 11 mission put human beings on the surface of another world for the very, very first time. And that first footprint, it wasn't just a mark in the lunar dust. It was a brand new chapter in our own story. It brought everything we've talked about, that violent birth, that rocky surface, its ancient history, one giant leap closer to home. Which brings us right back to today and leaves us with one last really fascinating question. We walked on the moon over half a century ago, and now a whole new generation is looking back up at it with brand new ambitions. So, what's it going to be? What will our next giant leap be?